Hello student, now we will see adder or summing amplifier. This is the adder circuit. This is the adder circuit of inverting amplifier. Why? Because all the input signals are connected to inverting terminal. We know the current relation in parallel circuit is what? This I1, I can see I1, current flowing through this branch is I1, current flowing through this branch is I2, and current flowing through this branch, third branch, is I3. Now, and current flowing through this branch is, I can say, I out. Okay. Now if I'll apply KCL over here, what the KCL says? Sum of incoming current is equal to sum of outgoing current. So can I say like this, I1 plus I2 plus I3 is equal to this IO. But this IO will comes with the minus sign. Why? Because the direction is in opposite. So this I1 is flow due to the difference between the two voltage terminal. For for an example, I say the voltage at this is VA. So can I say that V1 minus VA divided by R1? Yes. This I1 comes with V1 minus VA divided by R1. So same thing happened with this I2. This comes with the V2 minus VA divided by R2. Then I3 will comes with V3 minus VA divided by R3. So this V out is due to your V out minus VA divided by, I say, RF. Okay. So you have, if I'll substitute this all in equation, so I'll get the V1 minus VA divided by R1 plus V2 minus VA divided by R2 plus V3 minus VA divided by R3, which is equal to V out minus VA divided by RF. But the non-inverting terminal is at ground. So due to virtual ground concept, this VA will be ground. So VA will be 0. So after simplification, it will give the equation like V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3, and this will comes on this side, the left side will comes V out divided by RF. If all the resistors are equal, R1, R2, R3 and RF are equals, after the substitution you will get this all will get equal, and which will go this side will make a 0. So the equation will be like V out is equal to minus V1 plus V2 plus V3. So there are two types, weighted or scaling or weighted amplifier or averaging amplifier. In scaling, or we could say the weighted amplifier, the R1, R2, R3 are not equal to each other. RF is also not equal to each other. So we have to keep this one equation as it is because it is as a weighted amplifier. So it is used to scale of the input terminal as per the requirement. Then averaging circuit, in that case, all the resistors R1, R2 and R3 are equal, and the RF is divided by how many resistors are connected. Like I'll show you the R1, and if there are R1, R2, R3 and if R4, then all are equal, but the RF will be equal to R divided by number of values. If here are 3, then the RF will be R divided by 3. So this is called as the averaging circuits. Now the adder of non-inverting amplifier. So that means all the signals which are going to add or which are going to we have to add are connected to non-inverting terminal, and the inverting terminal is get ground through R resistors. So the same thing over here, the current flowing through each branch, we can say that I1, I2, I3. So same thing we have to apply over here. That is I1 is equal to V1 minus VA divided by R1. I2 we can say V2 minus VA divided by R2, and the I3 is equal to V3 minus VA divided by R3. Now we know the gain of this non-inverting amplifier is what? 1 plus RF upon R1. So what I'll do? The gain is equal to, we know, output divided by input. Am I right? So the output is equal to what? I got the value I got the value over here is like this. V out divided by here. The V out is equal to what? Or I can say the current flowing through is this, is what? IF. So the IF is equal to what? V out divided by RF. So I can substitute over here V out divided by RF. So instead of this V out, I can substitute, or this well equation I can substitute over here in gain. So the after simplification, the adder equation is like this. V out is equal to 1 plus RF upon R. Then the V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3. See, all the terms over here are collected to at the one place. This is after simplification. If I say the VA is grounded, so V1 divided by R1 plus V2 divided by R2 and V3 divided by R3 is equal to V0 divided by Rf. So we have to substitute these equations over here. So the instead of this VA, I can substitute V1 divided by R1, V2 divided by R2 and V3 divided by R3. So here I substitute all the equations, and the V out is equal to 1 plus Rf upon R and V1 upon R1 plus V2 divided by R2. So in exam they may not ask for the derivation. They may ask some numericals which are based on adder and the subtractor. So just we have to substitute this values, input signals, input voltages in this formula, and you'll get a final value. They may ask for the 10 marks, they may ask for the 5 marks in your paper. They may not ask the whole derivation for this adder for inverting as well as non-inverting amplifier. So don't worry about it. So to practice some numericals which are based on the non-inverting amplifier and the inverting amplifier adder. Thank you, student.